Hello everyone, and welcome to this knowledge clip where we explore more operations on relations, such as converse, join, projection, selection, composition, and image. Let's begin with the converse of a relation. The converse of a relation, R, denoted as R to the power of -1, is obtained by simply swapping the elements in each ordered pair. In other words, if the ordered pair AB is an element of relation R, then in the converse relation we have the ordered pair BA. For example, consider the relation R is a parent of. If the ordered pair Alice-Bob is an element of this relation, which means that Alice is a parent of Bob, then Bob-Alice is an element of the converse relation, which we can interpret as Bob is a child of Alice. It's important to note that converse is different from complement. The complement of a relation consists of all pairs not in the relation, while the converse simply reverses the order of elements in the pairs. Next, we introduce the join of two relations. The join operation allows us to combine two relations that share a common intermediate set. Imagine two relations. One relation relates employee IDs with employee names, and another relation relates employee names and their phone numbers. The join operation links these two relations by their shared attribute employee name to form a new relation that associates employee ID with their name and phone number. Another important operation is projection. The projection of a relation reduces its complexity by selecting only certain components of its tuples. If we have a relation over multiple attributes, we can project it onto a subset of attributes by ignoring the rest. For example, if a relation R contains ordered tuples associating an employee's ID, name, department, and salary, then projecting this relation onto ID and name results in a relation containing only those two fields. Projection reduces the number of attributes in a relation, but keeps all tuples that remain meaningful under the reduced structure. Closely related to projection is selection, also known as restriction. Instead of reducing attributes, selection reduces the number of tuples by filtering based on conditions. For example, given a relation of employees with their salaries, selecting only those with a salary above €50,000 results in a smaller subset of employees. Projection reduces attributes, while selection reduces tuples. Now let's explore composition of relations. The composition of two relations, S and R, written as S circle R, creates a new relation where an element A is related to C if there exists some element X such that A is related to X in relation R and X is related to C in relation S. For example, if relation R represents is a parent of and relation S represents is a sibling of, then S composed with R gives us the relation is an uncle aunt of. Finally, let's look at the image of a relation. The image of an element A under the relation R, written as shown on this slide, consists of all elements B such that the ordered pair AB is an element of R. In simpler terms, it's the set of elements that A is related to via relation R. For instance, if R represents is a teacher of, then the image of Alice under the relation R is the set of all students taught by Alice. This concludes our discussion on operations on relations. We have explored converse, join, projection, selection, composition, and image, each providing a different way to manipulate relations. Thank you for watching and see you next time.